Okay, hello grade 10s, hope you're doing well. We're going to be continuing on this week in our study of light and geometric optics. So where we are in your textbook today is section 11.1. We're going to be looking at curved mirrors this week. Last week we talked mostly about reflection and reflection in plane mirrors, so flat mirrors. This week we're going to be exploring what happens in curved mirrors. Okay, and then next week we'll be moving on to some new concepts. Okay, so this week really is going to build on itself. This first day we're going to be talking about introduction to curved mirrors and convex mirrors. Tomorrow we'll be talking about concave mirrors, and you'll be finishing off this week with a gizmo. Okay, please make sure, some of you still are forgetting that whenever a gizmo is assigned, it is required that you do the 5 multiple choice questions below the gizmo to show your understanding. Okay, so make sure you're not forgetting that, because that could be part of what you're seeing for marks, and you've seen that in the past. Okay, so what are we looking at today? So we're going to be talking a little bit about how funhouse mirrors work. We're going to talk a little bit about curved mirrors and the terminology you're going to need to understand to go through today's lesson. Then we're going to talk specifically about convex mirrors, and I'll assign you some homework problems for you to take a look at. For these problems, you might find it easier to print off the worksheets. They are sometimes a little bit trickier to do on a computer, unless you have like a tablet. So it may be easier to print these off and do them hard copy. You will need some sort of straight edge, so like a ruler, and a protractor may be handy for you as well. Okay, so by the end of the class, what we should be able to do is identify parts of a curved mirror and also use ray diagrams to predict the size and placements of images reflected off convex mirrors. Okay. All right. So if you've ever been to like a carnival before or a fair before, you may have seen these types of mirrors. They're usually called funhouse mirrors, where you can stand in front of them and your image that appears in the mirror looks a little wonky. Okay, it's not like what the same type of reflection you would see when you walk up to a normal plane or flat mirror, like in your bathroom that you may be using to do your hair or fix your makeup. These mirrors, they have a wave to them, and what happens is you see the image that is created is distorted as well. And that actually has to do with the way that light is reflected off those mirrors, because they are not plane or flat. Okay, it's going to impact the reflection. And we use these curved mirrors, specifically convex mirrors, all over the place. So you may have seen like store security mirrors before. They don't put plain or flat mirrors on the ceiling. They put these curved mirrors on the ceiling because the way that light interacts with them allows them to see a greater area of the store. So they may be able to see people who are trying to shoplift a lot easier. In the car, you may have noticed before, on your side view mirrors, it says things like objects are closer than they may appear. Same thing, those mirrors, if you actually go, next time you go out to the car and you run your finger along the side view mirror, or next time you're near a car, you'll actually feel that it's curved. It bubbles out in the center towards you. This again allows you to see more of the road behind you, limits your blind spot in a car, but it does manipulate the image a bit. So things are actually closer than how they appear because it's not a plane mirror, and the reflection is a little bit different. Also, sometimes security cameras, like on some ATMs, will have a little curved mirror, specifically a convex mirror, and again, it'll be able to see if someone's standing behind you in the far corners, to try to see if they can see your pin. Okay, so we use curved mirrors quite a lot in our everyday life for lots of different purposes, and a lot of them have to do with just being able to see a greater distance than you would, not a greater distance, but a greater area, okay, than you would with a typical plane mirror. Okay. So the neat thing about curved mirrors is they still obey the law of reflection. The difference is when parallel light beams come in, instead of bouncing off parallel like we saw in regular reflection on a planar mirror, the light rays are going to bounce off in a slightly different pattern, or a slightly different angle, because they are hitting the mirror slightly differently because of the curve. Okay, all rays will eventually meet at one point though, and that's where we actually perceive the image to be. Okay, so we can see another convex mirror here, a curved mirror like bubbles out in the center. on a corner where there may be a tight turn, so that drivers can see farther down the street, so they can see if any traffic is oncoming. Okay, so we have to go over some curved mirror terminology. Okay, this looks really confusing. It's a diagram for your textbook, but if we break it down, it's not that bad. Okay, first thing in this image here, this curve right here, that's the mirror itself. Okay, this specifically, this curve right here, okay, where the little lines are. This is called a concave mirror. These are the types of mirrors we're going to be talking about tomorrow, but the terminology is all the same. Okay, every curved mirror is going to have a spot that's labeled with an F, and that is your focal point. Okay, so anytime we refer to a focal point, it's essentially where all of the rays of light are going to converge. Okay, so it's really important to know where your focal point is. The other point that's really important is this point right here, which is called the vertex. Okay, the vertex on a curved mirror, okay, is right where the mirror interacts with the principal axis. So the principal axis is this line that's going right through here. Sorry, my line's not very straight, but that line right there is called your principal axis. Okay, and that's going to go from the base of your object, whatever is being reflected in the mirror, and we'll use that to help predict our image. Okay, the object right here is the thing that's actually being reflected. Okay, so if I'm standing in front of a mirror, I am the object, and what is created in the mirror, or the reflection that we can see, is called your image. Okay, so we have our focal point where all the rays converge. We have our vertex, which is where our mirror hits our principal axis. The principal axis goes to the bottom of our object, which is the thing that's actually being reflected, and what's going to be created in the mirror is called your image. Okay. Now we're going to go back. We did talk about this a little bit last week, but we're going to remind ourselves the difference between what's called a virtual image and a real image. So a virtual image, we did talk about this last week, is there's no real image where we perceive the image to be. So for example, if my phone here is a mirror, okay, and I go up and I look in the mirror, I'm gonna perceive that there's a person standing in behind the mirror. Okay. But if I actually could look physically behind the mirror, there's no light here. There's no hologram here of a copy of Miss Uliani on the other side. Okay? Just like in the picture here, the cat's looking in the mirror. It sees a reflection, obviously not an accurate reflection, but it looks as though that there's a lion standing on the other side of this like portal. So it looks as though to us that if we went and stood behind this mirror, we'd actually be able to see a lion. But we know, in fact, if we stood behind the mirror, we wouldn't actually see anything there. There would be no light getting there. So that's called a virtual image. Okay. So a virtual image is any image that's formed by rays that don't actually pass through the location where we perceive it. Okay. A real image is a little bit different. A real image is an image that's formed by light rays that actually converge at the location of the image. So what that means is, for example, back in our classroom at Tommy Douglas, if you remember, we have the projector on the board. It's a smart board. The projector is actually really close to the screen, and it's a special type of projector. It actually has a mirror in it that reflects the image onto the screen. Okay, so if we actually look at the screen, if we were back at Tommy Douglas and I went up to my smartboard screen, there's actually light on the screen. That's why if I was to stand in front of the projector, there would be a shadow created and you wouldn't actually be able to see the image anymore. Okay, so it's where an image is actually formed and light is actually getting to that location. So most often we see real images in projectors. A lot of really expensive projectors or nicer projectors have mirrors in them, and they're actually producing real images, not virtual images. Okay, so the point at which the light rays converge actually creates an image, so it can be projected onto a screen. And if the screen was moved away from that point, the image is going to be more blurry. Okay, so real images are made of light that actually is hitting that location. Oftentimes that is where we're going to see actually something being projected onto a screen. Virtual images are when you're looking into this like imaginary portal. Okay, like when we look into a planar mirror and we see our reflection on the other side, there's no actual hologram in behind the mirror. Okay. Today specifically, we're going to start off by talking about convex mirrors. Convex mirrors look like this. Okay. So it looks like a bubble out. So the highest peak is going to be sort of the center of the mirror here. These are often called convex mirrors. Okay, so something that pushes out, or also called diverging mirrors. They're called diverging mirrors because if we look at these rays that are coming in, as they bounce off, they're getting pulled farther and farther and farther away from one another. So they're kind of dispersing those rays or diverging. Okay. These mirrors spread out or disperse light, like we just said, and they always produce a virtual image. Okay, so it's going to be, if you look into the mirror, you're going to actually see the image in the mirror, like a normal planar mirror, a normal flat mirror. And it's always going to produce an image that's upright, so right side up, and smaller. Okay, so this is similar to the types of mirrors that we see on our car rear view mirrors. Okay, they are convex, they bubble out. Okay, and they produce virtual images. If we look into the mirror, I can see the world behind me in that little portal. Okay, and the images I see still right side up, but they're going to look a little smaller than they should have. Okay, so I'm going to show you this quickly just so we can see how these mirrors work. Okay, so we're starting, if we look at this video right here, we can see what's happens in a diverging or a convex mirror. Okay, as this mirror bends out, we can see that the light rays that are coming in are getting pulled away from one another, so they're all getting farther and farther and farther, and you can see they're getting farther and farther and farther away from each other as the curve gets more intense. Okay, all right, go back here. All right, so how do we draw a ray diagram? So these are the two steps. You can copy and paste these into your notes. Essentially what we're going to say, there's two main rays that we're always going to draw, and wherever they converge with one another is where we're going to perceive the image. Okay. It sounds a little confusing. I'm going to read through the steps quickly, and then I'm going to show you with an example because it'll make more sense once we see the example. Okay. So the first thing it says is draw a ray from a point on the object parallel to the principal axis. Okay, so if we look here, here's our object. Here's what's actually being reflected in the mirror. We're going to start at the top of that object. It's the easiest place to start at. And I'm going to draw a ray that's parallel towards the mirror to the principal axis. Okay, so you can see this line right here is parallel to the principal axis, which is right here. Okay, it's going to go do that until it hits the mirror. Now, remember, when it hits the mirror, it's going to reflect like light does in a planar mirror. Okay, and it says this ray will reflect through the focal point. So when it hits the mirror, I'm then going to make sure that the line, when it bounces off, goes right through that focal point. Okay, so the first ray that I've drawn right here is that one from step one. The second ray says draw a ray from the same point on the object through the focal point. So this time, instead of going parallel to the principal axis, I'm drawing this green ray right here. It's going to go from the top of the object through the focal point until it hits the mirror. When it hits the mirror, light bounces off of it, just like we learned last week. And it says this ray will reflect parallel to the principal axis. Okay, so we're going to bounce it back, okay, and it's going to go parallel. Where we're going to perceive the object to be is going to be where those 2 points converge. It also says, I would suggest always extending the real rays to form virtual rays behind the mirror. Now remember, anything on this side of the mirror, on the outside of the mirror we call it, is made of real rays. So it's made of light that actually hits that point. When the light goes here, it's actually going to bounce and it's going to come back. Okay, but we also know there are those things called virtual rays. So those are the rays that we perceive when we look inside the mirror that don't actually get there. So what I would suggest you do is whenever this light, the light that bounces off the mirror, extend that ray backwards. Okay, so it comes in and it bounces, that bouncing ray, we're going to extend it back into the mirror. Okay, because sometimes if a virtual image is produced, the rays are actually going to meet on the virtual side of the mirror. Okay, so let's do an example. I'm going to make myself disappear. We're going to go here and we're going to do some examples. Okay, so I have the steps still written for us here about what we're going to do. Okay, So step 1 and step 2 are still drawn right here. And it says, the first thing it says is ray is drawn parallel from the top of the object to the principal axis. Now remember, in a curved convex mirror, like we're learning about, the focal point is going to be on the inside of the mirror. Okay, we call this side, oops, oh, sorry, in a little bit. Call this side the inside of the mirror, okay, and we call this side the outside of the mirror. Now remember, whatever is on the outside of the mirror is going to be made of real rays, so that's where light actually goes. And on the inside of the mirror, we're going to see virtual rays. Okay? Rays aren't actually going to go there. Okay? So keep that in mind. So the first thing we're going to do, I'm going to take my ruler and I'm going to turn this. So my principal axis is right here, and I'm going to draw a ray that's parallel to the principal axis. Okay? From the top of the object into the mirror. So just like on the diagram, I'll do this one in blue. Okay, so a ray of light is going to go from the top of the object towards the mirror. Okay, so move this out. Remember, the light is moving in this direction. It's going towards the mirror. Okay, so a ray is drawn parallel from the top of the object to parallel with the principal axis, and the reflected ray is going to go through the focal point. Okay, so what I'm going to do now is I'm going to make my ruler go from that spot, but go through the focal point. Okay, so the light is going to bounce this way. And I'm going to extend this ray, and I'm going to do it with a dotted line. Okay, because it's on the inside of the mirror. So remember, anything on the inside of the mirror is made of a virtual ray. I'm just going to get that out of the way here. Okay, and I'm going to do it with a dotted line. A dotted line always tells us that it's a virtual ray. Okay, so there's my first ray that I've drawn. Okay, it went into the mirror parallel to the principal axis, and it bounced off the mirror. I knew the angle that it bounced off because it went through that focal point. Okay, now the next line that it says, I'm going to do this one in green just like the diagrams. It says a ray is drawn through the focal point. Okay, so I'm going to take my ruler this time from the same top of the object, and I'm going to make it so that it will go through that focal point right there. Okay, so I'm going to draw a line that would go through the focal point, but remember, it's going to hit the mirror and it can't go any farther. Okay, so this is where that object is going to bounce, or that ray of light is going to bounce. So now it's going to bounce off parallel to the principal axis. So I take my principal axis is right here. So it's going to get to the point where it meets the mirror. Okay, and it's going to bounce off or get reflected parallel to the principal axis. But again, we're going to extend that reflected ray back into the mirror. But I'm dotting the line to tell the reader that it's a virtual ray. Okay, so it went in, it was going to go through the focal point, it hit the mirror, so it bounced off, and it bounced off parallel to the principal axis. So I'm going to look, where do those two reflected rays meet? Okay, well, the two reflected rays meet right here. That is where I'm going to see my image be produced. So my image is going to be produced right where those two rays meet, okay? And it's going to be an arrow that goes down to that same principal axis. So a few things. So this is my image that was produced from my original object, which is over here. Okay, so a few things I can report about this image. First thing you're going to always ask about those images is it a real image or is it virtual? Oh, my pen's getting messy. So first question we're going to ask is it real or is it virtual? Well, in this case, because the image is on the inside of the mirror, and it's made of virtual rays, those ones that are dotted, we would say this is a virtual image. This is going to be one that if I actually look into the curved mirror, I'm going to see it's the image inside that imaginary portal. Okay, I also know that because it's on the inside of the mirror. Okay, and it's made of virtual, or those dotted rays. Okay, the next question that you may be asked, so perfect, is it bigger? Is it bigger or smaller? So it's asking, is the image that you created bigger or smaller than the initial object? Well, we can see pretty easily by comparing them. You could also use a ruler if you needed to measure. Okay. The object is obviously much bigger than the image, so it produced a smaller image. Okay, we can see the image that was produced, what's in red, is a lot smaller than the original object. The third thing that you may be asked is it upright or upside down? Well, we can see the top of the image is still above that principal axis. The image is always going to go back down to the principal axis. Okay, so we can see this image was upright. It's not upside down. So if you had to report on this image, you would say it produced a virtual image that was smaller and upright. Okay? Now let's try one more. Move this ruler down a little bit. We have another example right here. So I'm going to start off with my first ray. Like we said, the first ray is always going to go parallel to this principal axis. Okay? I'm going to go up here, 0 degrees. Okay, it's going to go in parallel to the principal axis. And how is it going to reflect? It's going to reflect through the focal point. So if I look, I need to make this point go through the focal point. Okay, I'll move a little bit farther, please. There we go. So it's going to reflect off as though it was going to go through the focal point, and I'm going to extend that reflected ray, okay, into the mirror with that dotted line to tell the reader it's a virtual ray. Okay, so that's my first ray. Parallel to the principal axis, then reflecting through the focal point. The next ray is going to go from the top of the object again, as though it would go through the focal point. Again, we know it's not going to be able to this time because it's going to bounce off the mirror, but it's going to go from the top of the object to the mirror. Okay, and it's going to reflect parallel to that principal axis. Okay, so it's going to reflect like this, and I'm going to draw that virtual ray into the mirror. Set out of the way. So it's going to reflect like that. Now we're going to see, where is that image produced? Where do those two reflected rays meet? Well, these two reflected rays don't meet anywhere. Okay, there you can see they're getting farther and farther away from each other. But on the inside of the mirror, we can see those two reflected rays meet right here. So this is going to be the top of my image, and it's going to go down to the principal axis. So again, what type of object is created here? Is it real or virtual? This is going to be a virtual image. Like before, it's made of rays that are inside the mirror, on this side of the mirror, and it's also made of those dotted reflected rays. We can also see that they're smaller. Okay, the original object is a lot smaller than the image. And we can see that it's also upright. It's not turned upside down. That should be the case for all convex mirrors. Okay? For convex mirror problems, when you're drawing ray diagrams, you should really always get virtual, smaller, and upright images. If you don't, you may have done something wrong with your ray diagrams. Okay? So there's 2 examples that we did for you. There is a summary table in your textbook, okay? And it says the same thing. When we look at convex mirrors, you're always going to see images that are virtual, that are smaller, and are upright, okay? So you're always going to see an image that looks smaller, but it's not upside down, it's right side up. And it's also going to be something you're going to have to be looking into the mirror to see. You're not going to be projecting those onto the screen, okay? Tomorrow when we look at concave mirrors, we'll be looking at some other examples of how those variables can be mixed up. Okay, so on Classroom, there is a worksheet for you, okay? We're going to be doing the same thing that we just did on those examples. So you're going to draw the ray diagram, okay? So this is your object. Whatever is beside the O, that's your object. The F here is your focal point. You don't need the C's, ignore that for now, and you don't need this information for now, okay? We're going to be talking more about that tomorrow. But what you need to do is first draw the ray diagram, so do what we just did in the video, okay? And again, like we did in the video, you have to report, is this image real or imaginary? Determine if it's upright or inverted, okay? Don't worry about finding the distance to the image or the height. We're going to be doing that later in the week. And for the magnification, instead of telling me the magnification, I just want to tell you to tell me, is the image bigger or smaller? Okay, you're going to do the exact same thing we did in the examples on that whiteboard. Okay, if you have any questions, reach out to me for some help. Otherwise, I hope you're all staying safe, staying healthy, and staying at home.